Hey guys, welcome. Now I know you might be aware of the incredible NLP capabilities that allows us to solve different problems such as text summarization, text generation, reference to context, automatic speech recognition, and so many other things, right? And then you realize, okay, this is such a key and important power that I have that you have at your fingertips, especially after the advent of ChatGPT. This is so much power. Having access to these LLMs is so much power, and then you decide to build something off of this. So obviously with great power comes great responsibility, right? Now picture this. You and your buddies realize that this is such a great opportunity to build some LLM based application, or when I say LLM, I mean large language models, right? Some LLM based applications. So you and your buddies get together, build the framework, come up with the application, and build probably the front end, the UI, and blah, blah, blah. Now, when it comes to the back end, especially at least the LLM, as far as the LLMs are concerned, the large language models are concerned, you know that they are just an API call away, right? However, you also realize that obviously you cannot just use the existing LLMs. You might have to, per se, fine tune for your use cases. Depends on what you're building. These can vary. And obviously, you might have to do some kind of fine tuning to these models so that they are much well suited for the application that you're building. So, picture this. So, you guys come together, you build everything. Now, the first issue that you will run into is gathering the data set. Now, let's say you figured out the data set, you kind of pre-processed it, and it's all ready to go, done and dusted. It's just a matter of using this data set and putting it to the model to fine tune the LLM model, right? But the first issue that you're going to face is the fact that you're limited by your GPU memory. That's the major issue, right? So let's say you have a 2080 or even a 3060. All of these are like 8 GB. So at least the consumer grade GPUs are limited in terms of their memory. Okay, that is the first issue. Now, let's say you get around that issue by taking the route of getting a cloud compute. Okay, fine. You eliminate that issue. Now, in cloud compute, depends on what compute you get, and the prices vary based on the compute. All right. But the second issue is that you run into, let's say the data set you gathered for your specific application that you're building is of the orders of 1 TB and more, typically, right? Because obviously we need good quality data set to get the best results in order to fine tune the model. So that's the second thing. So data propagation between your local computer and the server. And let's say you figure that out as well. The third issue that you will typically face is inefficient resource utilization of your GPU during the model training. So what I mean by that is you don't want your GPUs to be sitting idle between the data propagation between your local computer and the server, because you're paying for hourly basis, right? You're paying for the compute. And if your GPU is sitting idle during the transmission between your server and the client, right? So this is another issue. So how are you going to tackle all of these issues, right? Now let's imagine these. You've figured out all of this, but the major issue is, what about your accuracy? You figured everything out, you put your heart and soul into it, and you train, you work day in, day out, only to realize that your accuracy is not all that great. And you know that to converge to good accuracy, you have spent your compute, which means you've spent your time, money, everything, effort, blah, 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 but your accuracy is not that great. And then again, you have to retrain, which is again a problem. So it's not really a walk in the park. But hey, like I said, with great power comes great responsibility, and we have also managed to figure out how to eliminate these typical problems. So the first problem is, like I said, limited GPU memory, and we can get around that problem using Hugging Face, which I'm going to talk to you, which I'm going to show you, right? Slow training times. So how are we going to optimize the training time so that it does not, if we did not use these optimization techniques, it is going to take much more longer, right? So we have to reducing the training times, and obviously reducing the inference times as well. And how we can get around the fact that the GPU is being completely utilized, and we are actually paying for how much we are using, and not just simply paying for not using the GPU, for it simply being idle. So if this is something that excites you and you want to learn, stick around, because this video is going to give you a lot of value. I try to make it as much value oriented as possible. So do stick around and watch the entire video. So without any further ado, let's get started. Thank you.